Okay, so in this video we're going to enhance our filtering in the STL, especially the find if. I mean, these techniques could be used in multiple. I mean, not only in find if, but in pretty much everywhere. So the first way you're doing it, we will use the lambda like this and and capturing values from the outside scope. I will show you that in more detail in a future video. But let's just say that we have a variable instead. And I mean, typically we we might even read it in, but let's just say it's a variable. And instead of using the 90 here, hard-coded, we need to use the value from this one. And the thing to make this work is to, I mean, that's what these brackets are for. So you specify which values you want to access from the outer scope. So like this, it's completely possible to have it parameterized with a variable from outside. So let's, but I will show you a better way, I think. Actually, it's not, no, it might not be better. I mean, it always depends. But another, and I leave it up to you to decide when to use either way of doing this. But as you can see, it still works. So that was capturing values into the lambda. Okay, let's look at another way, and it's called functors. I mean, the problem with this is we do have some logic here. Okay, so this logic is not the most, I mean, complex, not at all. But I mean, typically you might have this code you might have in other places as well in your application and in other files and so on. So you might want to, I mean, you certainly don't want to repeat yourself. So is there a way to encapsulate? Should we call this an algorithm? I don't know, but this filter or algorithm, or is there a way to, I mean, to make a package of a function, and it is. Let's look at that. Let's see. I will first let's copy paste this, I think. All right. So instead, we are, oh, sorry. So this is about creating something called a functor. Actually, that's just a class. I typically, I mean, if you know, there is no, I mean, there is no difference between a struct and a class other than how the default access modifiers. But typically when I create something that's, I mean, this doesn't feel like a class to me. I tend to use, when I do these functors and so, I tend to use struct. I don't know why. To me, I feel like it's more correct semantically. I mean, yeah, we could always use a class, it doesn't matter. Anyway, so the struct then. Let's do a struct. Price filter. Okay, so we will have some private variables. And the thing is, I'm gonna use the mean price as a private variable. And as you know, I just told you, if you didn't know, we don't have to use a public if you don't want to, because the for structs it's public anyway. Okay, let's do a constructor, and it will take a mean price. And what I'm doing now, I'm trying to encapsulate this logic here, because as I said, we don't want to repeat this logic later on when we it's not the end of the world in this simple example, but it could be a somewhat more advanced filtering or something. We typically don't want to repeat ourselves. So what to do? So we create a class or a struct, and we first of all we encapsulate the price. So let's create one of these then. Here. So price filter, and we feed it whatever min price we're going to use right now. Let's say 90 or whatever it was. So now we have a price filter, and the thing is now we are gonna feed this price filter as to lambda, like this, and that's that won't work. And actually, no, it won't work like this because we are not done. But the thing is about C++ is you could make almost anything appear as being something else. So we could we could make anything like a class appear as a function. This is what we call, this is a functor object. So it will be an object that that is callable. And how on earth how are things called in C++ or any language? Well, you have some sort of name or variable, and then you just have the parentheses. This is how to call things, how to call a function or whatever. And as I said, it's possible to accomplish this in C++ by overloading the parenthesis operator. So have a look at this. Operator. So now we are, as you can see, not yet, but we will, when we're finished, we will implement this operator, the parenthesis operator. And this operator will be called from within, the find if. So it would take this thing and call it. So this will make any object callable. But the thing is, the find if will take a if we look at the old one, we should take a parameter, right? Yeah. So let's add this one as well. We can't use auto in here. So let's say movie, or like this. And I forgot this one. So the operator is the parenthesis. We do take a movie, and we should return true or false, because this is a predicate. Find if. Whenever we return true, it has been found. So this will yeah, like this. Okay. And the cool thing is that when findIf try to call this lambda or function, I mean, as you can see, we are in our struct or class, then we are appearing as a function. And the cool thing is that it's not a function, but it's a class, and it's a variable. It's a variable, and it has its own state. So it's now possible to create a price filter with 90 or 100 or wherever, and reuse it like this, and we don't need to rewrite this logic. So functor objects are, I mean, they are really really cool, really useful, and really beneficial to use when we want to, I mean, in a sense, write good code. Let's just see. So it still works. Yeah, it still worked. So this is another great thing about C++, and as you can see, it's one of the things that really make people turn away from C++. But I mean, when we start using C++ this way, instead of just looking at C++ as, okay, it's an enhanced C, so it's C but with classes. No, it's not. When we start using C++ this way, we really, I mean, your code will be much higher quality.